Okay, let's get started. So this is coming up soon. What day is it? Friday. Super. So hopefully it's not too surprising. So there are three main topics. Chapter 5, which is all about loops and whatnot. Chapter 6, which is about functions. And Chapter 7, which is about classes. So we will probably get to the material on structs pretty soon. We're not going to cover structs on the test. So it's everything through classes and objects, but just not structs. And then the test will be, so I figured, well, the majority of people struggled on the multiple choice and did well on the programming part. So what I thought was reduce the number of multiple choice questions and increase the amount on the programming part to make it better for you and easier to do to grade in a certain sense. So there will be 10 questions, multiple choice instead of 20, and then 2 programming questions. So there will be one question to implement certain things, and then another question to implement a different thing. Okay? And then there are 10 bonus points possible. So you could get 110 out of 100 if you wanted to. Well, if you could. Any questions about the test? Yeah.
So the actual sheet of notes that we can have.
Yeah, anything you like. Yep. Yeah. So a funny experience. So I taught a course not this past summer, but the one before, and I have a picture of this as proof. I didn't restrict the amount of size of paper, and as long as you don't disturb the person next to you. What happened is that this person brought in I'm not kidding, a literal scroll of paper that was like, I'm not kidding, 4 feet wide by like 10 feet deep, of like really tiny handwriting all the way through. He barely passed. But why do you think he barely passed and did horribly on the final, even though he wrote all those notes handwritten? Because he was spending all his time looking for something that could help him, and you know that the tests that I make are not going to be, you've never seen the questions before. So looking for the answer is probably a bad thing to do. So what I suggest for your cheat sheet is to put down any technical details that you might forget. Or maybe try to think about what things would I ask? Well, think about it. How many chapters am I covering on this test? 3. How many things on the test are there? 3. Well, 1 multiple choice section and 2 programming questions. How many is that? 3. So what do you think I'm going to be testing on? So that sort of thing, okay? If you've been doing the assignments and coming to class, doing the labs, you shouldn't have any problems. Well, minimal problems, yeah.
Is it like last time in one of the questions would be a lot like the assignments?
What do you mean, like the assignments we've been doing?
Well, last time you told us one of the questions would be very similar to
Oh, yeah. So the thing is, we haven't had an assignment on classes before. Well, we've the only assignment that we've done really is assignment 4, which was on chapter 5. So I can't really expect you to write something that's like an assignment that hasn't been assigned yet. So the things about programming questions here will be straightforward. So they won't be. So basically, we've been implementing functions and objects and doing loops and all that stuff. So basically, you would expect that you're going to be writing a class, a function, and loops somewhere in there. So, and they will be like some of the things that you've been doing in labs and whatnot, but they won't be exactly the same or close because I haven't assigned them yet. Other questions about the test? Yeah.
It's Friday, right?
What do you think? Yes. So, yeah, don't come next Monday. Yeah.
Actually, study for the coding
Yeah, so what I would recommend in this case is that you go over have I uploaded the code samples from the book for these chapters? If I haven't, I will upload them. So look over the code samples from the book, and I'll upload them if I haven't already. But other than that, I would look at the coding examples we've been doing in class, and those should be a major help to you. So the lecture videos obviously will help with that. Other questions? So of course, the assignment that we've been doing on loops, that should help quite considerably if I ask anything about loops. But it won't be anything as complicated as, say, assignment 4 is. It's just going to be a simple loop if there happens to be a loop question. Other questions about the test? Yeah. Yeah, so I'm not going to be here. So what I recommend here is get here early, because I'm not going to be the one passing out the papers, because if the TAs happen to not lay them out in the way that I do them, then I can't really say anything other than just come early. Your name will be on one of the exam sheets, so just come here early and try to find it, so we won't have any problems like we did last time. If you have a question during the test, it's fine to ask the TAs, but they haven't seen the test, so they may not give you an appropriate answer. So if you have an assumption you want to make, write the assumption down and proceed under that assumption. I'm going to try to make the test so that there's no need for that, but if there happens to be something that you're not sure about, just write it down and proceed under that. Okay? Any other questions about the test? Yeah.
So when it says it will require concepts from chapter 1, 2, and 4,
May or may not.
Is it like collectively, like from the beginning to now, or is it like just like you use some of those concepts?
It's just if you need an if statement, then it's not explicitly asked in 5, 6, and 7, and I'm not going to explicitly ask it on the test, but it's just you may need to understand if statements or else or anything like that. Any other questions about the test? Okay, so any questions on the assignment? When's it due? that was a lot more quiet of a response. So I can see the frustration. So has anyone ever been able to go through do the extra credit part? Yeah, so how long did it take?
3 hours.
Okay, 3 hours. So hopefully if you implement some of the optimizations that I have suggested to you, you should be able to do the extra credit without much problem. So it should take only a few hours. In my case, I got it within 26 minutes or so, just by thinking about some of the optimizations and what cases I can ignore and not check. Yeah.
26 minutes for the regular assignment?
No, for the entire one. Yeah. Yeah, so it's not too crazy of what I've done, but it's just thinking about some of the easy things that we could optimize. Yeah. Anyone have a question about the assignment? Okay, so last time we were going over this thing called an object, or an abstract data type, or a class. All means the same thing here. So what we want from these is to explicitly create a type so that instead of having a lot of boilerplate code in some main function, maybe we're doing something over and over and over, we can hoist that out into a class, and then it has the advantage of we only do the boilerplate code inside of the class, and the other benefit is when we view the class, we don't need to think about what it does on the inside. We just ask it a question by calling some method on it, and it gives us a result. We don't have to think any harder than that. So that is what is called object-oriented programming, because we work with objects and ask them questions, and they give us answers. So an example we've seen so far is the square. So we need to think, well, what kinds of data does a square actually need? So the only thing it really needs is the side. Because if we know the side, then we know, for example, the perimeter, the area, that sort of thing. If we wanted to add additional functionality, it may or may not be needed, but we have to think about what the application of adding that data gives us. So the class format is by saying class with the class name, so like square as the example we had earlier, where we have some private data, which is the data hiding and encapsulation idea we were talking about before, where we hide the data, the internal data away from the user, and then just expose the only things that we need for the user to work with our square objects effectively. So for instance, we expose in the public section two functions, a set side function and a get side function. So we're allowing the user to set the side, the length of the side, as well as retrieve the side of the square. But in some situations, maybe we would want only a setter function, and sometimes we only want a getter function. Like a bank account is the example I've been doing over and over. We only want to get a balance, but we don't necessarily want the user to say, oh, I'm going to allow myself to set the balance to be $1 million or whatever. But maybe we could have a set bank account balance option, but what else would we need in the set function in order for it to work correctly? Well, maybe we would want to say, oh, we're processing a transaction now. Let's have a check inside this set bank account balance function to say, is this transaction valid? Because if it turns out to be invalid, there's no reason to actually set the balance. But if it is valid, then we would want to set the balance. So if you think about what getters are necessary and what setters are necessary or are wanted by the user, that's an important part of object-oriented programming. So we initialize the objects, but just like we have been doing with ints, strings, longs, all that stuff, by just calling the type of the object, which is square in this case, and then we just make a variable like we've been doing before, and then we use the dot right here to say, I'm going to call one of the functions here. So sq1 dot set side calls the function set side of the square class. So it's like a normal function call, but we're operating on this one instance of sq1. So for instance, let's just say that sq1 and sq2 both have a side of 0 currently. So when I set the side of sq1, what is the side length of sq1? When I call that? 5, right? After I call that, what is the side length of sq2? Did I change sq2's side length? No. So these are independent objects, just like we have seen, but you need to be able to think about this where we say, oh, we're setting the side of on this object and not on the other one, okay? So set side, in this case, only operates on sq1. If I said sq2.setSide of 10, then that'll change the side of sq2 to 10 and not for sq1. Yeah?
Why do you need to have sq1 and sq2? I mean, isn't like a square root you just need like one side?
Well, if I'm working with two squares, then I may need to operate with that. Like, remember way back to assignment 1, where we had or I forget, maybe quiz 1 or something, where we had these cylinders that we wanted to check whether they intersected or were touching or were disjoint. Then we would need to know, okay, here's the object corresponding to the player, and here's the object corresponding to the obstacle or whatever. Then we need to work with both of those objects simultaneously. So maybe, for instance, our player is SQ1 and the obstacle is SQ2. then we would need to work with the two squares simultaneously. Okay? But it's initialized in the same analogous way that integers and strings and so forth were also initialized. But also we can call .getSide as well. Okay? The getter function is sometimes called the accessor function. I usually just use the term getter and setter because they're called get something or set something. By the way, does it need to be called set side? No, there's no rule that says you have to call it set side or you have to call it get side. But it's just the convention to say get the particular data that you want or set the particular data that you want. And do you have to do this only this assignment or just this return in these functions, or could you do something else as well? Am I required to do this exactly this operation? No. So this is just a convention. A getter should only get the data and not do any other work. And a set function should only do an assignment and do no other work. Okay? But it's just a convention. It could do something else if you want it to. So getters and setters. So we mentioned last time this thing called an inline function, which is where the function itself, the implementation, the code of the function, is directly inside the class. And then so those are the inline functions. But if we want to, for example, put the definition or the implementation of the function outside of the class, you can do that by just putting this double colon right here to say, oh, I'm not just making a function called getSide that just exists arbitrarily. I'm saying now this getSide function is part of the square class, okay? So this double colon just says, oh, I'm resolving where the scope of this function lies. Where does this function actually work? And we're saying it belongs to the square class. It's not just an arbitrary function existing randomly. Okay. So the convention, although it's not required that you do this, but this is just a good rule of thumb, is to say all of the member data is private to reinforce the data hiding and encapsulation things that we've been talking about. You have a question?
So we were speaking on a bank account. Second instance, we would put private, like, we would put int account, right? We would just be talking about the account balance, right?
Right. Mm-hmm.
And then if we were talking about the public part, would we do like the balance, I mean, not the balance, but the deposit?
Yeah. So like you would have a withdraw and a deposit public function. Because if so that's a good example. So let's actually run with that. So let's say, let's make a new project. Let's call it bank account. Yes, I want this window. So let's just get, actually we'll keep main. So I'm just only doing this for demonstration. So let's make a bank account class. And let's just say for demonstration purposes, don't do this in real code, but let's just say I make the bank account balance public. Okay, so I make the account balance public. Okay, so then maybe we have a double withdraw function and okay, so withdraw, we need to be able to withdraw some amount of money. So let's just say double amount. And then in here, we're going to subtract amount from balance. Okay, so whatever balance was before, we subtract the amount from it. And then if we want to deposit, maybe we want to say deposit some amount. And then here we want to add to balance. Okay. Well, what if I did this? So let's say I make a bank account BA, and then I can just say, well, the balance is public, so I can actually set that directly. So I can just say a huge amount of money, right? So am I allowed to do this with the current implementation of bank account? Is this going to compile and run correctly? No and yes. So let's actually see. So let's just print out BA.balance, which we can do. So it actually prints $10 billion. So why did this work? Why can't I just set the balance directly? Because it's public, right? So remember, by default, classes data is private by default. So if I put this here, it actually shouldn't run because I can't set this directly. I can't set balance directly because it's a private variable. If I make it explicit, I can just say private right here. But I can't set this directly. The only things I could ever do with respect to this object, this bank account object, is anything inside the public part. So I could, for instance, I could call .withdraw. So let's just say $100, for example. I still can't print it, but maybe what we could do is say, oh, should I be allowed to set the balance arbitrarily outside of the withdraw and deposits functions? Can I just set it directly? No, I shouldn't be allowed to set it directly. But should I be allowed to get the balance and not change it, but get it? Yeah, that seems perfectly reasonable. So let's have a getter function. So the nice thing I demonstrated last time is that if you control-click on an object, or mainly the class, then go down to generate, then you can actually generate any of these things. Mainly we'll deal with these two. So getter. So if I highlight balance here, it'll actually generate the balance right here. Okay, so ignore the const on the end. But so I can get the balance directly. So I'll get to you in a second. So if I print .getBalance, this will be completely fine, and I have a negative $100. Sad for me. Yeah.
Okay, so would you put the setup in the private? Would you set the balance in the private?
In some sense, yeah. So for instance, like if I wanted to deposit this amount, should I be allowed to just automatically add it to the balance? What should I do in addition to that? I should check, is this a valid transaction? Because if I just, like for instance, if I just wrote a check from somebody and I just wrote $10 million on it, and then I said, oh, I take a picture of it and I send it off to Bank of America, and should they be allowed to just automatically add it to my account? No, they're going to check whether it's a valid transaction or not. And so because of that, maybe we could have a function that's private that maybe handles the authentication part to check, is this a valid transaction? Should I expose checking whether it's a valid transaction to a user? Maybe, but it doesn't actually seem necessary here. The only things that we really should need for our bank account in this scenario is withdrawing, depositing, and getting the balance of the account. Okay, so but the only things that I could interface with this object are anything in the public part. I can't access anything in the private part. Okay, so I can call .getBalance, but I can't call .balance the data, the underlying data part. I can only access it through the public function. Any questions about this? Yeah. So why would I use void on withdraw and deposit? So like if I deposit $100 into my bank account, should I expect anything in return? Well, maybe a confirmation that it actually worked. So we have to be able to design our class to think, well, what things do we really want from this object? So, or from this function. So maybe, for instance, we put a string as the return type, and we say return. Let's say the amount was deposited. Okay, so maybe we can maybe. Oh, okay, I see what went wrong there. Oh, okay. Maybe I need to include string. Oh, yeah, that's... Okay, yeah, that should fix it. Okay, so ignore this part. Okay, so maybe we need to give a confirmation to the user, or maybe we would want to return the balance to the user. We need to be able to think, what is an appropriate thing to return? So, or maybe we don't want to return here. So maybe we want a function that prints to us the options of what functions we can call. So maybe it could tell us, oh, you can call get balance, you can call withdraw, you can call deposit. So it prints those to the user. Should I return anything from that if I just print to the user? Just like the menu of things you could do? Well, maybe. So that's the art of designing classes. You need to think about what things are appropriate to return. Maybe here we do want to return the balance. And in some situations, that might be a good idea. But like for set side of the square class, should I return the side? Maybe I would want to, but the convention is setters don't return anything. The getters obviously return something, but if we're somewhere in the middle, we're not setting and we're not getting explicitly, maybe we would want to return something. So you have to think, what is an appropriate thing to return? Okay? So withdraw, it might make sense to return something. And some other people may say it doesn't make sense to return anything. Any questions about classes otherwise? Yeah.
So further down in the main
Mm-hmm.
so did you just call the withdraw function with lock?
Yes. So here I created an object called BA of type bank account. So I call the withdraw method, the withdraw function, on the BA object using the dot operator. So BA dot, then you put a function, or anything that's public really, well, withdraw in this case, and then parentheses to provide any arguments that are needed. So if I had a different function which took 2 arguments, I would put something there with a comma and the other argument. Okay? Any questions about how this works? Yeah.
So why do you need the BA? Why should you say
Good question. So why can't I do something like this? So if I hover over this, it will say, hopefully tell me something. Yeah, so it says it cannot use a dot operator on a type. So, yeah, go ahead.
No, I was just going to say, the bank account's pretty much blueprints, and you're not going to change all of the bank account. You're trying to make another version of it and change that.
Yeah, so when I'm making this object right here, I'm making this bank account, let's just say for me. So this BA is unique to me. If someone else ran this exact same function, or the same code, their bank account should be different from mine, right? So for instance, if I wanted to make a string, let's just say s equals hello world, and then maybe we just print s out. So we're making here, it's the same thing. We're making an object called s of type string. So like for integers, doubles, bank account here, string, it's all the same type of thing. But I shouldn't be allowed to say string.length, for example, because this is a type. I need to operate on the length of one particular string. So one string's length may be different from another string's length. Same thing with bank account. One bank account's balance is different from another bank account's balance. So we're operating on each of the objects of type bank account or whatever. Okay? So, yeah, so that's why we are or creating objects of specific types. In this case, bank account. So if I wanted another bank account, I would just say BA2, for example. And then I could operate on BA2 if I wanted to. Okay? Any questions on how that works? Okay, so let's get back into here. So data is usually private, functions are public, yeah.
I'm sorry, I just had like a doubt about like the real life situation. So you're cards have chips on them, right?
Mhm.
So based on your card's chips, do they basically recognize which account it is, and from there do they like go through different like data to know what balance you have?
That's a fantastic question. So there's this algorithm called Luhn's algorithm, L-U-H-N, if you want to look it up, which is an algorithm to check whether a credit card number is a possible valid credit card number. If it fails this test, then it's definitely a fake credit card, okay? So it's a way of a credit card to basically self-check, to check whether this credit card number is valid. So then once say the register checks that the number is possibly valid, then it'll go out to the respective server, like Visa or MasterCard or Discover, and then it'll come back to do the check there to make sure it really is valid. Then it'll come back to the register and say, yeah, it is a valid number on our file. Now you can proceed with the purchase. Okay? So you may expect, well, maybe if we didn't go do that additional check out there, we could do a fraudulent transaction right here because we're not doing the additional check on their end. So it's just a preliminary check to check whether something is working or not. Sorry, what was your question?
It was pretty similar.
Okay. Other questions? Sorry, I love that algorithm, and maybe I'll assign it as a homework problem. Yeah.
Okay, so when it comes to like, I know this might be off subject, but when it comes to like apples and stuff, is that how they find the file?
How they find the?
The file. Like, if you have this type and this object, if it's so many objects, they only have to find one type, right?
Yeah, so every object can only have one type, yes.
But they have millions and millions and millions of objects.
Correct, yeah. So there are situations where we could have, I've actually, in some of my work, I've dealt with several billion objects simultaneously. So obviously you're not going to write bank account BA1, BA2, BA3, BA4, because that would be ridiculous. So we're going, after the object stuff, we're going to proceed with how do you actually work with a lot of objects simultaneously? So, but we'll definitely get to that sort of thing. Yeah. It's something called arrays if you want to look it up. Okay, so yeah, data's private, functions are usually public. Sometimes you don't want a function to be public, but most of the time they are. When you call the function, it starts executing the code in the function as you might expect. Yeah, so that's exactly what we've been doing. So we ended, I think, on this slide last time, where we said, well, when I create this bank account, maybe on the internal part of maybe some of the data on the inside, maybe we want to initialize some of the variables or do some computation right at the very beginning, right when I make the object. So for instance, like if you start a new bank account at some bank, maybe in some cases you provide some data. Maybe the default balance on this account is, say, $200, like they give you a bonus at sign up, or they give you some deals that you can get within the first few months, that sort of thing. If you set that up at the beginning, you want to do that right when the object is created. Okay, so a constructor allows us to do this. So the constructor here is a special type of function. So it doesn't return anything. It's not even void. It's just a special type of function which allows you to, so you have to call it exactly the same thing as the class name. So notice it's exactly the same as the class name square here. And then we can pass in any data that we want. And then usually in the constructor, we just set the data accordingly. So I set the internal data member called side to be the passed in thing called s. So if I, where is it? So if I create a square object and I call it square2, and then this right here is invoking the constructor. It's calling the constructor to say, oh, the thing that you're passing in is the initial side length that you want to set. So square 2's initial side length is 0 or 8? 8, good. So when I create this object, it's going to have the default, it's going to have the side length equal to 8. So let's go back and see if we missed anything. So, but sometimes, like for here, I don't put the parentheses on square 1. So there, maybe we don't want to necessarily pass in the data right now. Maybe we want to pass in the data at some later point. So that's something called a default constructor, okay? So a default constructor is one that just doesn't take any arguments, and either it just does nothing, or it just sets things to default values. So for instance, let's make 2 constructors for our, let's turn this back to what it was before. Let's just say we want to add 2 constructors to bank account. One that is just a default constructor, it doesn't do anything, and one constructor which takes in the balance and sets it accordingly. So let's do the default one first. So let's make a bank account constructor. So notice there's no return type on the constructor. Do constructors have a return type? No, good. Great exam question, by the way. Hint, hint. So here is a default constructor. So here, do I pass in any arguments to this constructor? No, I don't pass in any arguments. So, but maybe let's just do a self-check to make sure we're actually doing things correctly. Let's actually see out in here that we are in the default constructor. To see, yeah, we actually did call the default constructor. So if we run this, let's get rid of BA2. We should expect that it'll print default constructor. And in fact, it did. So it actually does go through the default constructor. But you may wonder, well, what if we put a different constructor that actually does take in a balance and sets our internal balance accordingly? So let's make a bank account constructor again. Okay, what's it doing?
Are you doing that noise or is that an actual fiction?
I'm a very good ventriloquist. No, I'm not doing that. I don't know what's going on here, though. Okay, I don't know what's going on. I'm going to quit and retry. But any questions on default constructors versus non-default? Yeah. So the thing within the parentheses. And I'll show you how to call when you do have some. Okay, so now it's back online, I guess. So here we're going, so notice I just duplicated the default constructor. Why do you think there's an error right here? So this is, remember what an overloaded function is, where we have 2 functions where they have different signatures, meaning that they have different parameters that are passed to them. Do these 2 constructors have different parameters? No. So in fact, it's ambiguous. Do you mean to call this constructor or this other constructor? But if I put an argument here, then I get rid of that error because 1 argument versus 0 arguments are different. So it's easy for the compiler to see which one we're in. So let's say in here we're going to explicitly just say, we start off with that amount, let's set the balance to be that amount. And then here we're going to say, let's just say 1 argument constructor, for example. Okay, so let's now make a different bank account, BA2, but now it's going to have a starting value of 200, for example. And then maybe we can say, oh, let's see out BA.getBalance, and then let's do the same thing for BA2, just to see what happens. So then, okay, I know what happened there. So it called the default constructor because the default one was made first. BA appeared first. Then BA2 appeared, and then we called the one argument constructor. So these are in the constructors when you're making the object. Then we print BA.getBalance, which is this funky thing. And then BA2.getBalance, which is 200. Why do you think it's this and not 0? Well, in this case, we actually are initializing it because not explicitly. So when you make an object, there's some runtime cost that explicitly assigns the default value to all your data in the function. That's why it's called the default constructor. So why do you think it's this, though? It's very close to 0, but it's not 0. So that's just one of the funky things with doubles. You may not be able to represent things precisely accurately. But if I used an int instead here, then it would be initialized to 0. So just be careful when you're working with floating point values. Okay. Any questions, though, about that? Yeah. So it's right here. So here is the double in int, but it's converted to a double. It's going to be passed into here because this is the only constructor with one argument. Then it'll set the 200 to balance in that object and not in the other one. Okay? By the way, what if I wanted to have a shared name across instances? So I want BA, the first BA and the BA2 to have, say, the name of the bank, a shared name between them to say, yeah, both of these are Bank of America accounts, but I don't want an independent copy between them. I don't want a string here to say, this account belongs to Bank of America, and a different string corresponding to the other object saying, this belongs to Bank of America. Anyone have an idea how we might do that? Where we have something shared across, there's only one copy of it? We actually talked about it last time. Or maybe the one before. It's static. So who remembers what static does? Yeah, so what does static do?
Whenever the function is terminated, the variable stays at the same value it had.
Right. But more importantly, if I call the same function over and over and over, there's still only one instance of that variable. So here, maybe we want to say, oh, we want to have a static string, let's just say name of bank is Bank of America. No, okay. Yeah, I need to put const here. Or maybe not. Static data type must be initialized out of line. I'm not sure why that is. Okay, I'll take a look at that. But that's the way that you're supposed to do it, to put a static on there to say, this string is going to be the same across all of the bank account instances. Okay, so that would reduce the amount of data that you use, right? You don't have separate copies of this string. You have exactly one string shared across all of the objects. Okay? Yeah, go ahead.
If you want to put a literal in there instead of a double amount for your second, then do you have to recall that again when you want to get the balance below? You have to re-put another 200 in seven parentheses.
So if I wanted to deposit, for instance, or what do you mean?
So
Mhm.
where you put double amount in second parentheses.
Yeah.
For your second, yeah. If you just want to put a literal there, you have to put that literal in.
You have to put a variable here. In the definition of the constructor. If I want to call the constructor, I can pass in anything I want. But the thing that's passed in, you need to actually say the type and the name of the thing. Yeah, so it has to be a variable. In the class definition itself. If I'm using the class and invoking the constructor, I can pass in anything I like, a variable or literal or whatever. But here it has to be. Even if I try to do this, this will not work because it needs to be an actual variable name. Yeah, so I have to put some type and some name here. Yeah.
Give me a real life example of where I would need to use the constructor.
So if you wanted to model an ASU student, for example, so there's this funky thing with the ASU system, and I swear I'm not making this up. So in some cultures, you might expect that most cultures you have a first name and a last name, but in some cultures what you have is that you're only known by one name, either a first or last name, but not both. So when you try to sign up for ASU, you have to put a first name and you have to put a last name, right? But because of visa reasons, you can't be expected to put anything different than what you're actually known to, as. So what happens here is, if you put your one name as your first name and put nothing as your last name, the last name is explicitly initialized to be, I'm not kidding, no last name as one word. So there are students here who are known by whatever their first name is, no last name. And in fact, I've seen a no first name too. So the reason why we have that sort of thing is maybe we want to set up an ASU student where they only have one name. So I need to have a constructor where it passes one name in. But maybe, of course, since a lot of us have first and last names, we need a different constructor which takes two names. I haven't found one student who has 0 names, but I'd be interested to know. But that's the main reason why we need different constructors to handle different behavior.
Argument would be that they have only one name.
Yeah. So here you would have the parameter be just one string, and then in the case of the other constructor, you have one string, comma, another string to denote first and last name. Other questions? Okay, so a few more slides before we quit for today. So this is just the default constructor, the thing that doesn't take any arguments at all. So we saw this. So when you set, so this isn't really that important yet, but it will be important, so it's important to pay attention to this. So when you create an object, like the bank account object, you might expect, of course, that it's going to take up some memory in your computer. So when your program quits, you actually want to free that memory back to the system and say, yeah, you can use this memory again. I'm not using it anymore, you can use it now. So that's the purpose of a destructor. So the purpose of a destructor is when this object is going to be destroyed, maybe you want to handle some other things to help free the memory back to the operating system. So if you allocated some memory in your code inside the class, here you may want to free it back to the system. So if we wanted to make a destructor for bank account, what you would do is put tilde bank account, and then you would do anything in here related to destroying any of the data that you have here. Because the object's about to be destroyed, you may need to do some additional things here. For right now, we don't have to worry about this because all of the objects that we've been working with already either have their own destructor or are just freed automatically for you. You don't need to implement your own destructor yet. But when we get into some more advanced stuff, you actually will need to do this. So it's just a heads up for that. Okay, and then let's see. So private functions, you can have private functions. You can pass arguments, you can pass objects to functions if you want to, like you can pass a string, or interestingly enough, what you could do is initialize one bank account with another. So you can pass in a bank account and initialize a new bank account with the same parameters, for example, as the old bank account, which is pretty interesting. But we'll get to that next time on Wednesday.